Hello and welcome to my channel. In today's video, I'll explain how to use G02 and G03 instructions to cut arcs in metal, plastic or wood simply and easily. Before I begin, do me a huge favor and hit the like button below to make it easier for other people to see this video, and please subscribe to my channel. The idea for this project started when I needed to round off the end of a flat bar that would become part of a stabilizer for my camper. In the past, I would have inked the surface, found the radius, scribed the shape of the semicircle, ground away the excess material, then finished the shape with a file. This time I decided to write a G-code program to mill away the excess material. I ended up writing several G-codes to cut a quarter, half, and full circle arcs using inch or metric units of measure, and I will share them with you. My G-codes are very short, less than 25 lines of code. Let's look at the basics first. In this picture, the XY origin is at the top right-hand corner of the rectangle. The radius of the arc is 1. The overall width of the arc is 1. To write a G-code to cut a clockwise arc 90 degrees, we use a linear instruction G01 to position the spindle at x minus 1, y0, which is the start coordinates for this arc. Then we use the clockwise circular instruction G02 to cut the arc. x0, y minus 1 are the end coordinates for this arc. I, followed by a number, is the distance and direction from the start of the arc to its center point along the x-axis. For this arc, I is 0. J, followed by a number, is the distance and direction from the start of the arc to its center point of the arc along the y-axis. For this arc, J is minus 1. If we were to input these two lines of code into a MIDI dialog box, the first line of code would move the spindle to x minus 1, y0 at 10 inches per minute. The second line would move our spindle in a 1-inch radius clockwise arc 90 degrees at 10 inches per minute. To move a spindle 90 degrees in a counterclockwise arc, as shown in this picture, the start coordinates are x0, y minus 1. The end coordinates are x minus 1, y0. I is negative 1 and j is 0. To move the spindle in a 180 degree arc with a radius of 1 inch in the clockwise direction, the start coordinates are x minus 1, y0. The end coordinates are x minus 1, y minus 2. I is 0 and j minus 1. To move the spindle in a 180 degree arc with a radius of 1 inch in a counterclockwise direction, the start coordinates are x minus 1, y minus 2. The end coordinates are x minus 1, y 0, I is 0, and j plus 1. It is very easy to write a code to move the spindle in a full arc. We use G2 to move the spindle in a clockwise direction, or G3 to move the spindle in the counterclockwise direction. The start coordinates and end coordinates are the same value, I equals 0 and j equals minus 1 for both the G2 and G3 instruction. To cut an arc to size, we need to take into account the diameter of the cutting tool we will be using to calculate the cutter compensation for each of our coordinates. CNC programs will do this automatically if we use a G41 or G42 cutter compensation instruction in our G-code. However, things got complicated when I tried to cut an arc in a clockwise direction, then return the cutter counterclockwise to its original starting point using a G3 instruction. I will show you how I came up with a different way to automatically allow for cutter compensation later in this video. Now let's look at a G-code I wrote to cut a 90-degree arc in a workpiece that is 1 inch thick. The first line of code is the file number 01, followed by comments that will be ignored by our CNC program, but will help us to stay organized. The radius of our arc, when the G code was written, and who wrote it. The next line is another comment indicating the diameter of our cutter. In line 10, G54 specifies the fixture offsets. For most of us, G54 is the CNC program's default setting. Line 20 is our safety line. G90 to use absolute measurements. G80 cancels any canned cycles. G20 to use inch measurements. G40 to cancel cutter compensation. And G17 to select the XY plane. Line 100 is written using a G-rapid instruction to raise the spindle to a safe height. This helps us to avoid crashing our cutter into the hold-down clamp or ruining the surface of our workpiece when we move the table or spindle. In line 110, the cutter rapidly moves to X minus 1.25, Y 0.25, the start coordinates for this arc, allowing for a cutter compensation of 0.25 inches, which is half the diameter of our 0.5 inch cutter. In line 120, there are optional features. M3 to start our spindle, S2000 to set the spindle RPM to 2000 RPM, and M8 to start flood coolant. In line 130, we lower our spindle to Z0, the top of our workpiece, at a feed rate of 10 inches per minute. In line 140, M98 calls subroutine 10 and sets the number of loops the subroutine makes to 4. Each loop will cut minus 0.125 clockwise and minus 0.125 counterclockwise for a final depth of cut of 1 inch. Our CNC program skips over the next two lines, then runs subroutine 10. In line 170, G91 is for incremental measurements. Line 180 lowers our spindle minus 0.125. In line 190, G90 is to use absolute measurements again. Line 200 has a G2 instruction with coordinates X 0.25, Y minus 1.25, I 0, and J minus 1.25. These coordinates were also calculated to allow for cutter compensation. In line 210, another G91 to use incremental measurements. In the next line, 220, we lower the spindle minus 1.25 again. In line 230, G90 to use absolute measurements. In line 240, a G3 instruction is used to cut a counterclockwise 90-degree arc. Its coordinates are X minus 1.25, Y 0.25, I is minus 1.25, and J is 0. If we look back at line 140, the number of loops is 4. This subroutine makes 3 more loops, cutting minus 0.125 in the clockwise and minus 0.125 in the counterclockwise direction in each loop, for a final depth of cut of 1 inch after 4 loops. After the 4 loops are completed, M99 ends the subroutine. The main program executes line 150, a G-rapid move, raises the spindle to a safe Z height of 0.5. M9 turns the flood coolant off. In the last line of code, line 160, the spindle is positioned rapidly to the workpiece origin at X 0.25 and Y 0.25. M30 stops the spindle and the program rewinds back to the first line. Let's load this G code and run it in a simulator. I will edit the program, changing the number of loops to 1. Then increase the feed rate to 150%. The spindle raises to 0.5 inches, then moves to the start of the arc. The spindle lowers to minus 0.125, then moves in a clockwise direction until it reaches the end of the arc. The spindle lowers another minus 0.125, then moves in a counterclockwise direction to the end of the arc. The spindle raises to 0.5 inches and returns to x minus 0.25, y minus 0.25, the origin. To allow for automatic cutter compensation quickly and easily, I combined each of my G codes into one spreadsheet. If you've never used a spreadsheet before, don't worry. My arc cutting spreadsheet is very easy to use, easier than falling off a log. It is completely free if you download an open source office program called LibreOffice that includes a spreadsheet program called Calc. Or you can use other spreadsheet programs such as Microsoft Excel or Google Sheets. Google Sheets is a free online spreadsheet program. I will leave a link in the description to download LibreOffice. Once you have a spreadsheet program installed on your computer, you can download and open my arc cutting program. I will leave a link for my program in the description below. When you open my program, the first sheet you will see is my SAE 90-degree arc sheet. When you open my program, you may not see the entire sheet. Simply click on View and choose 90%. That should reveal the entire sheet. Now, let's play with the dimensions of this 90-degree arc. The spindle speed, feed rate, depth of cuts, and the safe Z height. At the top of the list is the overall width of our arc. The radius is calculated by dividing the overall width by 2. Notice that the radius has changed also. Several of the X, Y, I, and J coordinates changed as well in the box below and in the G code. Changing the depth of cut also changes the number of loops, and the finished depth of cut changes immediately. If I change the cutter diameter, the X, Y, I, and J coordinates change as well. We have the option of cutting to a depth in a clockwise or counterclockwise direction, and in both directions. Most of you will want to climb cut in a clockwise direction only. If you do, enter a 0 for the G03 depth of cut. The last thing to modify is the safe Z-axis travel height. You can change this value to avoid having your cutter crashing into things such as hold down clamps as the cutter is being positioned before and after we cut an arc. The numbers in these 8 cells are the only changes you should need to cut a quarter arc to size. To open a different sheet, click on one of the tabs at the bottom of the sheet. I abbreviated their names using a longer name caused some of the metric tabs to be hidden from view. The next sheet, SAE 180, is very similar to the SAE 90 sheet. The obvious difference is the pictures on the left. The next sheet, SAE 360, is laid out differently than the first 2 sheets. There is only one picture on the left, and we can only cut in one direction, either clockwise or counterclockwise. To choose a counterclockwise direction, enter a 3 instead of a 2 in this cell. The metric sheets use millimeters instead of inches, and the box colors are blue instead of pink. The feed rates are in millimeters per minute. Other than that, they are very similar to the SAE sheets. All of my sheets are write protected to prevent us from accidentally making unwanted changes to the sheet or G code. The 8 cells we played with today are not write protected. If you try and modify any other cell in the worksheet, a dialog box will appear letting you know that the cell is write protected. If you need to unprotect the sheet and make changes, you can. There is no password. I was tempted to require you to enter the words like "and subscribe" as a password, but I did not want to be a shameless promoter. Plus, I wanted the program to be as user-friendly as possible. To create text files that can be loaded into a CNC program, we simply highlight the entire G-code in the worksheet by left mouse clicking in the top left corner of the G-code box, then drag the mouse to its opposite corner. Release the mouse button. Right mouse click, select Copy, open a text editor such as Notepad, right click in Notepad, select Paste. Save the file in a convenient location, and we have a text file ready to load into our CNC program. If you just want to make quick changes to the code, such as changing the number of loops to test run the program, we can simply edit the G-code text file like I did earlier after the file is loaded into your CNC program to change the number of loops to 1. I recommend setting the Z-axis to 0 at a safe height above your workpiece before running a program for the first time. Some people call this an error cut. If you are satisfied after running the shortened version at a safe Z height, edit the file again to restore the G-code to its original number of loops. Reset Z0 to the top of your workpiece and run the program to cut your workpiece. I saved a copy of each of my G-codes on a thumb drive. Now I will load them and quickly run them with one loop and a feed rate of 250% using an older Mach 3 demo program running in Windows 10. Beware, some people have had difficulty running Mach 3 in Windows 10. If you have difficulties, contact Mach 3 for support. If you are a Linux CNC user, please let me know if my text files are compatible with your Linux CNC program. Switching from SAE to metric is very easy. The only thing I noticed was that the graphic view of an SAE program was smaller after I ran a metric text file. Regenerating the toolpath restored the view to normal size. You should be able to run my metric G-codes without making any changes to Mach 3. My metric G-codes have a G21 instruction in line 20 to set the units of measure to millimeters. Have a look at my other videos if you'd like to see more CNC projects using spreadsheets to easily mill square holes and to create drill bit trays. Early on in this project, I mounted my workpiece on parallels in a machinist vise. Then I set the X and Y origin using an edge finder to set the X origin at the back edge and Y origin at the right edge of my workpiece. I made an air cut. Then I set my Z height to 0 at the top of my workpiece and ran my program. I was not 100% successful in my first attempt. The program ended before cutting all the way through the material. The culprit was the formula that I used in the worksheet to calculate and round off the number of passes when necessary. A wonderful college software instructor showed me the error of my ways, and I was able to apply what I learned to solve the problem for us. Thanks, Gloria. Other than that, the program allowed me to cut a 180-degree arc on the end of my workpiece smoothly and accurately. Before providing you with this G-code, I ran them one last time with wood. Now that I am satisfied that it works properly, I will provide a link in my description below. Well, that is how we write a few lines of code to move a spindle in a clockwise or counterclockwise arc using G02 and G03, how I wrote a G-code to cut a clockwise or counterclockwise arc with a different method of setting cutter compensation, and cutting in multiple loops in less than 25 lines of code, and how we can use a free spreadsheet program to quickly modify my G-code to suit your needs. I hope that you found this video useful, and I hope that you can create a project to help other hobbyists. Thanks for watching.